Hey everybody, this is Larry. This is Weekly Contest 190 Leetcode. Hit the like button, hit the subscribe button. Let me know how you did, how you solved the problems, and yeah, kind of excited. 190, that's a big number, right? Yeah, I don't know. Anyway, wish me luck. Wish you had a good luck, and yeah, now I'm just trying to calm down. My goal this contest is just to not get wrong answers. I've been a little bit sloppy lately, so we'll see how that goes. Anyway, let's get started. And here we go. Q1, check if a word occurs as a prefix of any word in a sentence. So this one, it's looked pretty straightforward. I thought it was pretty straightforward. So I just implemented it. But as soon as I saw it, I was like, okay, this is just brute force. Let's let's check each word by itself, and then that's pretty much it. I look at each sentence and I look up each word, and for each word, I check whether the search word is the beginning or the prefix of the word, which there's a function in Python for doing it. So this is, in that sense, pretty straightforward. I ran the examples. I did it zero index. I was like, wait, that is not right. And I just wanted to read to double check that one index is okay, because sometimes it might not be. And I had to read the problem a little bit. As soon as I saw the word one index, I'm okay. But this cost me like 10 seconds or 20 seconds. Cool. Q2, maximum number of rows in a substring of a given length. So this one was a sliding window as soon as I saw it. Um, yeah, so this is sliding window. I was just thinking about how to implement it, and I think I've implemented this pretty quickly, as you will see. But the idea, and this will be part of the explanation, so don't worry if it looks like I'm skipping a little bit. But basically, for each character, we increment or we have a sliding window, and we move from left to right, and so forth, right? And as we add new characters, we check whether that's in A, E, I, O, U, and also we remove characters and then check to see if they're A, E, I, O, U, and then in those cases, just increment and decrement appropriately. Um, yeah, there'll be more explanations, so don't worry. That's pretty much it. I'm not really needing to talk that one. But yeah, but after that, you take the best of all the cases, and there you go. Everything match, everything feels good. That's it. Q3, pseudo palindromic paths in a binary tree. So this one, I did take a little bit more time to read the problem at least. And the thing I didn't know what it means was I don't know what a pseudo palindromic means. But I think I figured out by reading the first example where two, but um, like, okay, maybe. I'm still not super sure at this point. I think the other thing that I was looking for when I'm reading this, and you see me spend some time reading this problem, is wasn't sure what the definition of path means. And that seems like a silly thing to say, um, but it's true because I wasn't sure because a path could mean different things or people define it differently, and it wasn't clear from this problem what the path is. And you see me spend actually a little bit long time because I wasn't sure. But looking at the constraints, node values from 1 to 9, so I think I could do it. And um, I did eventually read that path is from the node or from the root to the leaf. But yeah, but I seeing that the node values are from 1 to 9, I was like, okay, I could just keep everything in a bit mask. I think in retrospect, I didn't need to. I could probably just kept it in an array and subtract and add and do a normal backtracking type thing. Um, but but I don't know. I just I think I innately worried about performance a little bit, and it's not that hard of a optimization, so I didn't really have to worry about that part. Where if I use an array, then I don't know, I would have be worrying the entire time. And this is a quote unquote easy optimization, in that I've done it enough times. Um, and that's also one thing that's a little tricky for me in Python, is that I love to do for loops that are less than or equal to from 1 to 9 or something like that, and that'll be really precise as to what I want, versus this +1 exclusive range thing, and that's why I was a little bit yeah, but basically I explained it a little bit more in the explanation portion, so feel free to skip ahead to get to that part if you just want the explanation, because I think I typed this too fast for me to explain everything. And there are a couple of things that I did before I got to here, so definitely, uh, no, yeah. So I did spend about, so I type out, and this is basically, I use current as a bit mask to keep track of the numbers that we processed so far. And here I'm just thinking a little bit of, okay, how to handle the, like, how do we add the number into the set actually, right? So we did the check, but then now we're like, okay, let's actually do it before, and then that doesn't make sense, or like you have to keep on doing it. So yeah, a little bit, I wouldn't say sloppy, just I implement this in a way that you could kind of see that I was uncertain about what I wanted to do, and that ultimately cost me some time. Um, but the worst part was that is this part, I think, because now it seems like that I spent about 2 minutes on this as a result. Basically, the answer is wrong, and the reason is why, and it's because I processed the first node twice, and that's very unfortunate, obviously, because I processed it in part of the first kicker. And some of this is because, and I mentioned in the explanation, um, is that I'm doing this in a way that's different than how I usually approached uh, these processing problems, and that is giving me cost a little bit. And I was double checking the bitwise operation because, yeah, but that cost me a full minute and change. And I tried to print it out. So I definitely, debugging in real time is expensive. So that's why practice if you want to get better, and so that you don't make these silly mistakes in the first place. Um, Watching this is a little bit painful. Spent 2 minutes here at least, and that would have been the difference between a top 5 finish and what I finish or something. So now I'm just going back and forth on the examples just to see, like, okay, what's going on. Like 8, that's a bit mask for 3. Why is that? I was like, okay, let's actually just print out the recursive steps, and also let's just change the one that we need to debug. And then I think as soon as I saw this, I looked at, and I guess I was very fortunate to agree. I looked at the value for the first node, and the first node was 0 by the time it's processing. Um, and that means that the node 0 was not processed. And then I was like, oh, excellent. That means that I processed it twice. And some of this debugging, even what I just said, is from a lot of experience of making these silly mistakes. So I was like, that cost me a full 2 and change. I ran the code, looks okay. The answer is right answer. I commented out one code and waiting for it to not fail. And that's pretty much for this problem in terms of contests. Stay tuned for the explanation, as always. And then I submit, and it was good. Q4, max dot product of 2 subsequences. So this is, as soon as I saw it, I was like, okay, this feels like a dynamic polling problem. I refreshed and I saw 5 people submitted already. And I was like, well, it is what it is. But yeah, but this is dynamic programming, straight up. I looked at the N and the M's, and it was 500. So I was like, okay, that should be fast enough. But the idea here, and some of this is just a lot of practice and recognizing the type of dynamic programming, and some of that is also just knowing dot products. I talk about this a little bit in the explanation, so feel free to skip ahead a little bit to that if you are interested in the explanation by then. But the idea is that given two lists, you have a couple of things you want to do, or you can do, which is you do to the beginning of the list, which is you take one from the left and then you remove it, or you take one to the on the list two and then remove it, or you take the top from the first from both of them and then do the operation. In this case, a multiplication, and then solve it. And some of this does require having experience with dot products, I think. I mean, or at least in terms of solving it is very quickly, because I don't think I even looked at the definition of dot product for this problem. Even for Leetcode, I would be really surprised if they changed the definition of dot product. That would have been funny, and there would have been some debugging time later. But that's essentially what I did. Set up right now. I'm setting up the base case. But yeah, but even then, even here, I knew that I had to worry about the case where the best answer is a negative number, meaning that, so I'm trying to think about the base case, and that's what you see me pausing here for a couple of beats for, because I wasn't sure how to handle that case, because I knew that 0 is not a good return result in that case, because it is bigger than your best number. So yeah, but I was like, okay, let's get this done first, and then, like, I think there are ways to think about it. So let's get this done, and then we'll figure out how to be a little bit better. And also, I have terrible variable name for infinity because it should be negative infinity, I suppose, and that's part of the confusion. But yeah, but now I'm just doing the DP part of the transitions, which is take the best of I plus 1 to move the index over, or j plus 1, moving that index over. And that's pretty much, and then now I was like, okay, so what am I doing, right? So what is the cost of taking the top and the bottom? And I was like, oh, it's just dot product. So we could just sum it by, and I double checked that my dot product definition at this point. But yeah, and I just returned best, and that's pretty much it, kind of. So I spent an extra minute trying to figure out what to do with the negative case. Yeah, I saw big negative numbers, and I was like, oh wait, why am I getting big negative numbers? Oh yeah, these should be max. Oops. Because that was just my infinity. That was like, okay. So I got the first two. So I know that now I'm confident about it, but I knew that I had to handle the negative 1 case, obviously. And this time, this contest, I did read the examples and not just submit without checking it. I was like, how'd I handle it? Okay, let's start with a started variable or dimension. There are other ways to do this, and I talk about it in explanation, so watch that for other ways of doing this. But I added a variable so that that I pass through, just to make sure that at least one item is, one sum is calculated. That's what I did, and that's what I submit. And as soon as I'm ready, and that's my contest. Hang out with the other Larry for explanation, and just post retro thingy. Bye bye. Okay. 13 minutes. But yeah, it was an easy set, so I'm sure someone would have done, or a good amount of people did it faster. Yeah, just a little bit of top 10. I spent too long on Q3. Oh, because that was a silly mistake on Q3. But can't complain anytime you finish in 13 minutes. But so what did I do in Q3? That was a mistake. So the Q3 was that I set the kicking off case wrong. I mean, I could show the code. So give me a second. As usual, right after contest, I do need to catch a breath because these things are tough. 13th, yeah, okay. Yeah, really could. It was definitely a set that I could have done faster, but I thought I was pretty okay. I don't think I could have done that much faster on any of the problems except for Q3. And to be honest, I probably could have been a minute or 2 minutes faster, but that's maybe it. Because that was a little bit silly on what I was doing. But if I was 2 minutes faster, I guess I would have been top five. But that's not a. It will happen. This is a tricky one to do in. I mean, that was a tricky one to do in like 5 minutes or so. But the reason why got the reason why I was slow was because I started off. I thought I was trying to be. I mean, I don't know if I was trying to be clever, but I thought that I had to. I thought that to start this off with setting it, but because I do this before I do the count, then I double counted this, and that's why I was wrong. And that took about a couple of minutes. But otherwise, the code was pretty easy to write. I could have done faster, but look, at the end of the day, I did a contest with no wrong answers. I think that's what I set out to do. I knew that was going to be a little bit slower, but you know, um, but that's okay. But a relatively easy contest because a lot of people finished within like 13 minutes. I would have expected to be top 10 to be honest, but I guess there are also a lot of people nowadays, so but so it's okay. But but it is obviously still a easy contest. But the one that killed me was apparently Q Q3 though, because I did Q4 pretty quickly in less than 5 minutes. And I was a little bit slow on Q4, but that's okay because Q4 I think I just wasn't sure that that could be good enough um, because it's a Q4, so January it's going to be a little bit slower. Let's refresh one more time just to make myself feel a little bit better. Now it's still 13th. Um, yeah, okay. Ooh, Alex just finished. But just giving a shout to Alex. If you're watching this, give him some love. I'll put a link to his channel on in his Discord channel below. Also join my Discord channel, I suppose. Uh, there's also going to be a link below. But ooh, let's go over the problems now. Check if a word occurs as a prefix of any word in a sentence. Um, this one, the solution is just to brute force it, because the sentence length is at most 100. The search word length is at most 10. So you can actually start by any character and then go and search for the word and it'll be okay. The only tricky part about this is that you have to return the index of the word index. So what I did is I used Python magic and I split the sentence uh, with the spaces. So and using enumerate, which maps the content of a iterator with like a counter of sorts. Uh, so so if for each word that is in sentence, if the word starts with the search word, then I just return the ith index. And the only tricky thing that cost me a couple of seconds, which I guess is okay, is that uh, it's one indexed, which I was like when I look. And this time I did look at the example test cases, which was a mistake that I did last week by accident. Um, and I was like, okay, everything's off by one. Let me double check that it's one index. And when I saw that was one index, okay, and then I submitted, and there was a case where the word is not in it. So I was like, okay, if it gives -1, then I think I'm okay. So yeah, so that is Q1. Overall, a easy problem. Is it an interview question? I guess it could be. I mean, it's too simple, but it's good practice, good warm up. Definitely recommend it. Complexity, it's O of where n is the sentence and m is equal to search word, then it's O of n times m. Technically, you could also analyze it in terms of number of words, but it's roughly right. Space, I use own extra space, O of one extra space. So yeah, so that's Q1. Q2, maximum number of vowels in a substring of a given length. Given a string s and integer k, return the maximum. So this is, I think, so I got this in about 1 minute 40 seconds. And the reason is just because this is a very standard sliding window problem. And I think I've been in a little bit more practice about it. historically, I've been actually really bad at sliding windows with respect to off by one. But the two things, one is that I've been kind of, I would say actively practicing, but I've been practicing um, just by doing more problems. So that is something that you get a little bit better with. And then the second thing is, um, this is actually, I mean, this is a easier sliding window problem. The conditions are pretty straightforward. So the idea behind this problem is sliding window. And if you're not familiar with sliding window, you should, well, practice it and read it out. But the idea is that given a string, let's just random, given any string, you keep track of the k numbers variable characters in it, and when you slide this window, hence name sliding window, when you slide this to the right, well, what does this look like, right? So these are the two problems that you saw from the previous problem, the last one. So then the difference is you adding the character A, and then you're subtracting the character T, right? And because here we only want to count the number of rows, when we see an A in the incoming character, which is X in this case, variable names are a little bit terrible, but this is contest, so, excuse me a little bit. And then if if the index is bigger than K, that means, or greater than, that means if we're going past this, then we have to subtract the one that we moved. And if that's an AEIOU, which is a wow, we minus the count. And then we just keep on taking the best count that we can as we slide and going. And that is Q2, the algorithm. Slide window comes up all the time in interviews and competitive programming, as you see here. So, but even in more, and generally in more difficult formats, but it's still a great practice, so definitely recommend it. What is the complexity? The complexity is just O of n, where n is the size of the S. And that should be apparent because we look at each character at most once, or well, at most once coming in, and then at most once going out, so at most twice. And so that's O of n. We don't use much extra space. We only have some O of one number of variables. So this is O of n time O of n O of one space, and can really do better than the lower bounds. So yeah, so that's Q2. I think the idea is very simple conceptually. The only tricky thing for me, anyway, historically, has been like off by ones and stuff like this. So it's very important to kind of have the right visualization on how you do the index. And as long as you have that, it'll be okay. For me, it's about sometimes I have my right bound is inclusive, sometimes my left bound is inclusive, and sometimes the exclusive. As long as you define to yourself exactly what they are, then you could be a little bit more better with the visualization, which allows you to have cleaner code quicker. So yeah, Q2. See, okay. Q3, pseudo palindromic paths in a binary tree. So this one is recursion, and this one was the one that this problem was the problem that I took the longest on this contest, unfortunately, because I don't know, maybe I could have been top 10, but that's okay. 13th is fine. But the key thing to note is that, well, one thing about a little bit meta about this problem is that it was a little bit annoying that I don't define what path is. I was looking for it a little bit, so probably like 20 seconds, say, what the definition of path is. And it mentioned a little bit here that the path's going from root node to leaf nodes, but it would be nice to have a little bit of definition. And you may wonder why, is the word path, it's obvious what it means. Well, the thing is, people do if you have enough experience, people do use it in different ways in competitive. So it's really nice to have that definition because when you assume you know the definition of something and someone throws you a curveball, you're going to spend a lot of time debugging. So that's what I wanted to make sure, and I have done that in the past, right? So yeah. So the idea is that, well, to be honest, I probably should not have done it this way because it really didn't save me that much time. But the key thing to notice for this problem is that, well, n is 100,000. Each node can have only can only be between 1 to 9. So what I did was I did a recursion I did a recursion. No, but I solved it with recursive formula. The formula being the node and the current bit mask. And why do we use a bit mask? So basically, we use a bit mask to just keep track of a set. Um, and why do we keep track of a set? I think I skipped ahead a little bit because pseudo-palindromic, what does that mean, right? And it's kind of also terrible because actually, I guess they explained it okay, but I think the words were a little bit hard when I was solving the problem. Um, but the idea between palindromic, yeah, is that you have this some path, and then the values can be rearranged in a palindrome, right? And the and if you kind of remember, I think some of this requires knowing or practicing with palindrome, but from that, you get the idea of how you construct a palindrome. Well, there's only two types of palindrome. It's one where it's an even number palindrome where each of them match, meaning you divide it in the middle, and then the left matches the right in a mirrored kind of way. And then the second type of palindrome is an odd numbered palindrome, and that means that you have one number in the middle that's could be any number really, and then you have left and the right of that middle number, and they're mirror image of each other, right? So kind of to illustrate that a little bit, you know, so to help your imaginations, you have two type of palindromes, which is like ABCD, DCBA, and the other one is something like that, right? Um, so you have that odd number in the middle or not. So those are palindromes, right? So the way that we thought about it is the way that we can think about it is that, well, given this string, how like or given the another way of rotating it, if you another way of thinking of the problem, or the problem is asks you, well, given a string or a sequence or whatever, how can you check if there's a palindrome subset or permutation, right? And the way that we did that was to figure out that, well, actually, in this case, it just means that there are only two cases. One is if it's even number, then that means all the numbers match off, right? Meaning there's a even number of each of them. Like they're either in twos or in fours and so forth, because you can imagine there's another A and that'll still be okay, right? And then the other cases, if there's odd number of them, then all of them pair off except for the one in the middle. And that could be any number, as I said. So what I did is I used a set, going back a little bit, I used a set to calculate, to keep track of what's in the current recursion, each node in the recursion. So you can think about here, if we start at the 2 on example 1, we go to 3, our set will contain number 2 and 3. And then we go back to the leaf, well, we see 3 again, so now we remove the 3 because it's the second time. So you kind of do that parity to kind of keep track of the number of numbers that way with a mask. I don't know if you can get it to work with recursion, but you could also have I think there might have been easier ways to do it, but that's the way I did it, in the sense that I worried during the contest, I worried about just the time. I worried about running out of time, because another way you could do it is just, given that algorithm, now that I think about it, but it didn't occur to me, to be honest, during the contest. But then, but you can keep track of with an array of 9 numbers, and then just go through the for loop, and then make sure that all of them are even except for one, like one odd count or something like that. And that maybe actually, now that I think about it, maybe it's okay. So it's just that during the contest, I think as soon as I saw it, I knew what I wanted to do. So I didn't really think about a more naive way of doing it, and maybe that's why people are able to do it much faster. But that wasn't even why I did it that slowly, right? But that's the recursion. So you kick it off. So now my code is. So I use a bit mask. So some of this may be a little bit harder to read, but but basically I have a current bit mask, and then now I flip the bit that's no that values bit. So if this is a 2, then we flip the second bit and so forth. Technically off by 1, but because it's one index, but that's okay. And then now we check whether this is a leaf. If this is a leaf, which means if left is none and right is none, then we count the number of bits that are in the set. And if the number of bits is 1 or 0, which is what this is, then we increment the count. Because if it's 0, that means it's an even number string, even numbered side string. And if it's an odd number, or if it's 1, then it's an odd number string, and that's okay. And then we just sum that all up. And that's pretty much my recursion. The thing that I spent a lot of time was that I did this in a way that that I didn't usually do it. So that's why it's a little bit, I think what I should have done is I should have done it my usual way, which is that usually my recursion already has the node.value into the recursive part of it, because that's more intuitive. But this time I changed a little bit to facilitate this if statement a little bit early, because this is not the base case, or it is a base case, but you have to take account the current node. That's just a little bit different of how I did it. I probably could have, now that I thought about it, I could have just put this in here and also here and here. Even though that looks a little bit more awkward, it is more natural to how I handle my base cases. And then from that, you will always have to kick off processing the first node. So here, I didn't need to, but I did in the way that I implemented in the code as you saw me live. And that was what I debugged for a couple of minutes. I have to print it out to see, oh, snaps. That was not great. And usually a couple of minutes is okay, but this contest was apparently a really easy one, so everyone did pretty quickly. So space-time complexity. So space is all of, sorry, let's do time first. We look at each node at most once. We process each node once, and it takes all of 1 for each node to process, because it takes like 10 operations or whatever. So that's going to be O of n running time. In terms of space, so that we don't use extra space that much except for this. But we do allocate stack space, and this could be a linked list of a tree, right? So in a linked list style tree where every node is on one side, then it's going to be O of n because you allocate that much space to it in terms of stack space. And you can't do better than that because, well, that's just, or you could call it O of h for height if you want to call it that for space, but yeah, whichever you prefer. But yeah, this is a good interview problem. This is a good competitive programming problem. It's recursion. Everyone should expect to know recursion on interviews. It's a little bit of a tricky one with kind of, there are a couple of steps going from pseudo palindromic to the recursion, but it is something that you should be able to figure out. And this is a Q3 on Leetcode, which is supposed to be a little bit harder. So take your time, but overall it's okay. It's a good practice, and yeah, and I think that's all I have for this problem. And it's fun. It's great. I like this problem actually, even if it cost me a couple minutes. Cool. Q4, max dot product of 2 subsequences. So this one, I kind of knew it was dynamic programming already, because it is a very, as soon as I saw it, I knew that it was just like, you keep, I knew what a dot product was, so I didn't have to read the definition, which helped a little bit. But the idea is that, the idea is that you're always given nums1 and nums2, you're given a couple of choices at every step for the transition, which is that you take the first number of both arrays and then you do the dot product, and some of this requires having experience of the dot product and stuff like this, in the sense that you're able to recognize that when you add stuff, like they're independent of each other and stuff like this. So there's stuff that you only get from experience or knowing what a dot product is and playing around with it. But because I already did that, I was able to speed that through. But idea is that because these are for that product, it's just a summation of a lot of products, um, and we could enumerate the products in this way with dynamic programming with the recursion, where we just either take the top of the beginning of the two lists, and then you multiply them, and then you add it to the current sum, or you skip the left one, and then you check the right one while keeping the other numbers the same, or you skip the one on the right, and then you keep the one on the left the same, and then you take the max of the sum over that. Uh, I think I knew that that was a way to do it, and then after that I was like, okay, let's look at the n, and n and m is less than 500, so I was like, okay, that should be fast enough. So I didn't really have to think about it anymore. But yeah, but that's kind of my thing. I have some terrible variable names, um, but yeah, so that's kind of my code. I mean, it's 20 lines of code, not even kind of. I use LRU cache for the memorization, but the tricky part, and I knew this while I was coding it, was that the tricky part was I didn't know how to handle the case where, well, the max is negative, so how do I change to the base case, right? Because you want the base case, or I wanted the base case to be zero. So I think there may be other ways of handling this, and I'm curious to see how you or other people did, just in general, because I think you could have maybe did some clevery thing where you do like brute force one element so that, and then take that as your max. Uh, but but I did it this way instead. It's actually probably takes way more space for that reason, but you could still keep it better otherwise. But yeah, but here we check to move the nums1 index to the plus one. We check the nums2 index plus one, and here um, we check taking the first number from each sequence and then summing it, and then incrementing from best. And so they, like I said, the thing that I did, which is a little, I don't know if that's how people would do it, because I think there are a couple of ways to do this to handle the at least one number case, but with the best number may be negative, and that can only be the case if um, that can only be the case if you only take one number from one numbers num1 and nums2, and you can prove this because if there are two numbers that are negative or two combinations that are negative or something like that, then you can have just one number that is negative, um, that is much is a max, is a bigger negative, or a negative number that's closer to zero, right? Because if you have two negative numbers and you add them, then that's obviously going to be a worse negative number. And if if the two numbers such that one is negative and then the other one is positive, then you just take the positive number, and that will obviously be a bigger number, so that wouldn't come up. So you can actually brute force the case, and then check that if like for I is equal to nums1, for j is equal to nums2, if and then keep the max of that going from and if that max is smaller than zero, then you just take it because you can't do better. Um, but if you can do better, it would have been positive, and then you could have done stuff. But the way that I did it was that I was a little bit. So all that stuff that I just said, I wasn't able, I think I had that idea, but I didn't want to prove that it was true. And sometimes, if you don't prove something, the proving part takes effort, takes time, and sometimes your proofs can be wrong, right? So what I did instead was I did this thing called started variable, which is also already part of the cache. But what I'm saying is that if we at least added one number, that means if we took this path once, if we add at least one number to the list, then that means that is a good list. And that means that our base case could be zero because that means that we already handled it. If we haven't started yet, then the answer is just going to be zero. Or you want the answer to be actually this is negative infinity, so the variable name is terrible. But you want it to be infinity so that you never take that path. And that's kind of because you never want to consider that as the best answer. And that's essentially what I did. And this is pretty straightforward. I did it in about 4 or 5 minutes, and a lot of people did as well, or a lot of the top people, because, well, I mean, this is like really easy to write. And I'm also sure that a lot of top people have already experienced dot products like I have. Um, but yeah, that's what I have for this problem. Let's refresh again. I don't know if I just expect my rank to go down because sometimes the Chinese server will merge in. But look at this. Wow. 15 minutes south and you're still 25th. So that's a really tough. I mean, this is a really easy set, but a really tough set to compete against. For that reason, uh, yeah. But it seems like I finished Q4 pretty quickly. It's just that my Q3 was a little bit slow. But yeah, but overall, I mean, 13th is pretty good, I think. So let me know what you think. It would be nice to be in the top 10 or even a little bit better. But wow, top 3 is 10 minutes. I don't think I could shave 3 minutes off what I was doing. But maybe I could have been top 5 if I was a little bit faster in Q3. But it is what it is. Anyway, that's all I have for today's contest. I'm really happy. And leave, leave a like button. What? Well, leave a comment. Let me know how you did, which one you struggle with, which one was your favorite problem. Uh, hit the like button, hit the subscribe button, and I will see y'all next week or whenever. Bye bye.